Hey, hello everyone, welcome back to the channel. So today we'll be solving a new problem that is peak index in a mountain array. So as you have already guessed it that okay, so if this is a peak index, we have to find the peak index. So let's dive into the question and the problem statement. So the problem statement is that we have given this mountain array. So this is our mountain array, right? Show you the so this is our arrays 0, 1, 0, these arrays that I have written here also. Okay. So in this array, we have to find the peak element index. What it means is that, so we have given this array length where the values increase to a peak element and then decreases. So it goes something like that. Okay. So suppose we have a graph, so it will keep increasing until the point it reaches that would be the peak. And then in that case, after that, it will keep decreasing. So this is basically the meaning of peak that okay, this is the highest point in the array or okay. So this index we have to find. So at what index this is getting the peak. Okay. So this is the problem statement. So we have to return the peak element. So first we will try to solve it using the brute force approach. And after that we will optimize it to log n. Okay. So for the brute force approach, what let's dive into the intuition part. Okay. I hope you understand the solution, the problem statement part. So let's dive into the solution part. So how we will think about it. Okay. So let's see. So there's one thing that you will be observing is that to the peak element, right? So the left element, this one would be less than the right one if it is increasing, right? If it is increasing, then there can be two things. If the array is strictly increasing, right? So the left one would be less than the right one, right? That is the basic case that this left one would always be less than the right one. Okay. And if it is decreasing, it means that we have already found the peak array or peak index. Then after that, in the decreasing case, it will do what? It will keep decreasing. Means that the left one would be greater than the right one, right? So I'll just place the left one here. So we are left, then we are here right. Okay. Then after that, we are left here and right here. Okay. So in that case, this left would be greater than the value of I. So this is the two observations that we have made. Okay. So now we don't have to like cater these both cases because this is just the vice versa of that. Okay. So what we have to do is now, so what we can simply iterate in our array and check that okay, if the value of the previous one, right? Suppose this is the first index and this is the zeroth index. So the first index, or let's say take left and right. So if left is less than right, it means that we haven't found the peak element yet. Okay. So we will keep increasing. Okay. We will keep incrementing our I or left and R, right? Both. There can be two things. If the array is strictly increasing, right? So the left one would be less than the right one, right? That is the basic case that this left one would always be less than the right one. Okay. And if it is decreasing, it means that we have already found the peak array or peak index. Then after that, in the decreasing case, it will do what? It will keep decreasing. Means that the left one would be greater than the right one, right? So I'll just place the left one here. So we are left, then we are here right. Okay. Then after that, we are left here and right here. Okay. So in that case, this left would be greater than the value of I. So this is the two observations that we have made. Okay. So now we don't have to like cater these both cases because this is just the vice versa of that. Okay. So what we have to do is now, so what we can simply iterate in our array and check that okay, if the value of the previous one, right? Suppose this is the first index and this is the zeroth index. So the first index, or let's say take left and right. So if left is less than right, it means that we haven't found the peak element yet. Okay. So we will keep increasing. Okay. We will keep incrementing our I or left and R, right? Both of them. But we can simply do one thing. Let's don't go into this. That I think that can be a bit complex. This two pointers thing. So I'll just simply take the for loop, right? That way you will understand it better. That okay, we'll check each pair like the previous one, this one. Suppose this is the ith one. I'll take this ith one. Okay, this 10 is the ith one. So we'll check this ith element is less than the I minus 1. Okay. So if that's the case, then what we have to do, it means that we haven't found the peak element. Okay. So we will simply traverse ahead. Okay. Now we will traverse ahead. Our I would go here. Okay. Now we'll check that. Okay. If 10 is less than 5, no, that's not the case. Then this was the condition. So we are not satisfying this condition. So we'll move into the else part, and else we will simply break out of it, right? It means that we have found the peak element because the element that is ahead is now going, will now go down because we have got the peak element. Okay. So this is the basic intuition for the brute force approach. Okay. So this brute force approach will take big O of n because we are traversing the array only once. Okay. So I'll simply write down the code. So in this code, what we are doing is that, so we are currently iterating through this array. Okay. So for each element, we are checking that, okay, if this condition I have just simply reverse the condition because in the if condition, we don't have to do anything. In the else part, we were using just breaking out of the loop. So I was just simply checking that, okay, if the reverse condition, it means that if the array of I minus 1 is greater than array of I, it means that this left, right, this is greater than this element. It means that we have found the peak element. Okay, because we are traversing from left to right. Okay, because we are traversing from left to right means that it is guaranteed that okay, this will be the peak, right, from left to right, and this would be the downfall of it. Okay, so if that's the case, we'll simply break out of it and we'll simply return the value I minus 1 because after breaking, so it will go up here. Okay, so we have to take the I minus 1 index. So if we'll try to submit that because the constraints are too high, so I think maybe it can, oh, it accepted. Okay, but it won't be pretty much efficient because yeah, it's not that much efficient because this is a big of an solution. So let's dive into the login part. For the login part, I think you have already guessed that we'll be using a binary search algorithm. How? So I'll simply explain that. In the binary search, we just had to take a couple of things. So the first thing is that we have to take the left and the right pointer. So we'll simply take the left and the right pointer. And after that, we'll simply just take the value from 0th index to the I length minus 1 index, right? So in this case, it would be 0, 1, 2, 3. Okay. So this would be the third index. We'll start with 0 and with right value 3. So in the binary search, what we do is simply just take the range, right? And in that range, we simply find the middle value because this range, this left and right, this is our range. So it's like 0 to 3, third index, we will go. And we will be finding a mid value. Okay. So for this value, we would get 2. Okay. Sorry, not 2, but 1 because 3 plus 0 by 2 would give us 1 only. Okay. So we will go here. Our mid will go to 10th index. Sorry, the first index. The value at first index is 10. So we will check that. Okay. So now the condition here comes. So for the binary search, the most important thing is that how we move our pointers, right? So to move our pointers, we have to check the condition. So according to the question, what do you think can be the condition? So what we have to do, we have to find the peak element, right? So to find the peak element, what we have to do, we have to check for the element. Suppose this is the element, right? So the left part or right part, whatever you want, you can choose. I will choose the left part. Suppose that this is the mid element, okay? So I'll take the m plus 1, okay? This one, okay? So I'll simply check that, okay, if this value is greater than this value, right? It means that this is the peak, okay? So we'll take the otherwise condition. So what we have taken previously, okay? So it means that, okay, so if m is less than m plus 1, what it means? It means that we have to decrease our left pointer. But in this case, what we have gone to the else case because this is not the matching condition. So after that, what we will do, we will simply move our right pointer to mid. Why? Because as we know that the peak would go down. Okay. So if this 10th element is not less than 5, it means that our peak can be in this side, okay, in the left side of it. Okay, in that case, when we have to move left, we will simply increase our right pointer. If you remember that, okay. So what we will do, we will simply shift our right pointer to mid. Okay, right. If that's not the case, suppose for example, let's not take 10 5, let's take 5 or 2. Okay, just for the example. So this is not the right case, okay, then we will also move to this part, okay. The right will move to right. Now take 0 and 10. In this case, this condition satisfies it. It means that our peak would be on the right side of it. Okay. So to move right, we have to shift our left pointer. To move our left pointer, we will simply use our mid plus 1 to left. Okay, understood? So this is the basic algorithm or the technique that we were using from couple of videos. So this is that. If you have not seen that videos, I'll highly recommend to watch the other videos. So now coming back to the question. So our right pointer is now changed to mid. So that is 1. So now we will calculate the mid value again. 0 plus 1, right? 0 plus 1 by 2. So 0 plus 1 by 2 would give us 1 by 2 and 1 by 2 is 0. Okay. Now we will check that, okay, if 0, we'll check 0 for the conditions. Okay. So if 0, we'll check for this condition is 0 less than 10 because m plus 1 is 10 right now. Okay. So this is true. It means that we will simply increase our left pointer. Okay. So we'll increase our left pointer to mid plus 1. So mid was 0 plus 1 would be 1. Okay. Now in this case, in our binary search, we had our condition that, okay, while left is less than right, we will iterate through this array. Okay. So, but this is not the case right now. So this left is equals to right now. So that's why we will get out of the loop, right? So this is the intuition part of it. So I'll simply write the code so that you can understand better, right? So you can also do the dry run for these two test cases on your own, okay? That way you will understand it very clearly. And if you get any doubt or something, you can just look at the video again, right? Or you can just add the comment, then I can help you with that. Now to write the code, what we have to do, we have to just use our binary search template. If you have watched our previous videos or if you remember that, okay. So what we have to do, we have to simply use our left and right pointers. And after that, we have to just add the condition to move our pointers. Okay. And after that, in the end, we simply return the answer. Okay. Coming back to the template. So actually there are two kind of templates. So in the first one, we simply use the while left is less than equal to right that I have used in couple of my videos. And there's one more that, okay, so in this case, when left is less than equal to right, if you remember, we use an additional array or additional variable result, right? So we simply return that and store the value in our right pointers mid. Okay, I'll show you the both of the code, right? So there's one more template that, okay, so if you don't want to use that one, or if you don't want to use any additional return result, okay, so what you can do, you can simply use this left only. Okay, so the answer would be stored in this left variable. So I'll show you now. We'll simply use our get our left and right ones. Mid will calculate the mid value. This is to get away from the overflow things. That's why I'm using this one. Now comes to the condition part. So in this condition part, what we have is the condition, if you remember that, okay. So if array mid was three, if array mid was less than equal to mid plus one. Okay. So if array mid less than array of mid plus one. If that's the case, what we were doing, we were simply incrementing our left pointer. Okay. So we'll simply change our left pointer mid plus one. Okay. If that's not the case, then we were simply using return is equals to mid, or we can use the mid minus one, right? I'll show you with the mid one also. Okay. Oh, sorry, I'll show you with the mid minus one. Okay. Minus one. Okay. So this is how we were using in our previous binary search template. So that's why I've been showing you both of them so that you can get the idea of both. So whatever you like, you can use. So in this case, we will simply store our value in the left pointer because we won't be iterating till the last, like this left would be equal to the right. Okay. The final result will simply return the left pointer. Something is missed. Sorry. It has to be on the outside the while loop. This is accepted. So now we will just submit it and let's see. Yeah, I think it is submitted and it's pretty much efficient. So this was the solution for the binary template that was using while left less less than right. Okay. So in this case, we will store the answer in the left variable because we won't be going till the final one. So if you will dry run it on your own, I highly recommend that you should dry run it before just writing the code, submitting it. Just use this template and dry run on your own. That way you will understand better. Okay, and that's why this is the thing that I have uh, left for you. Okay, so you have to do these things on your own and let me know if you have any issues or problem with that. Okay, so for this one, you have to do it on your own. Okay, so I think this was the code for it. So talking about the time complexity, so this is a binary search, so this will take big O of log n. Okay, so this is it for this question. So I hope you have understand this question. So if you have any question or doubts, you can drop it in the comment section and let me know about it. And thank you everyone so for your time. So I'll see you in the next one. Bye bye.